We read and hear a lot about radioactivity on the television, in the news, in our newspapers, and yet sometimes we're not all that clear of what radioactivity is. In this program, I'd like to tell you a little bit about radioactivity. Where does it come from? What is it? What are the problems with radioactivity? And what are the useful things about radioactivity? So first of all, let me begin standing here in the beautiful environment of Bhutan, standing above Thimphu with the Tashi Chodzong in the background. What a wonderful, unpolluted, clean environment we're in. Surely, you must say, there can be no radioactivity here. But the first thing I want to tell you is that radioactivity is all around us, even here in Bhutan. Where does it come from? Well, there are three main sources of radioactivity in our lives. We call it background radiation. The three main sources. One is from the sky, from outer space. The other is from the ground, and the other is man-made. So three main sources of background radiation, even here overlooking Thimphu. Let's just look at them a little bit more. All the time, coming down onto the Earth from outer space are rays called cosmic rays. Cosmic rays. And these are little particles which come down at incredible speed. They go so fast they will penetrate through 20 feet of concrete. They're coming through our bodies all the time. As I stand here and hold out my hand, cosmic rays are passing through my hand from outer space. We can do nothing about it. The human body has learned to live with them. We also have got radioactivity constantly around us in the rocks. Here's a rock. That is radioactive. The most radioactive sort of rock is granite, but all other rocks are radioactive too. And the soil, the sand that I've got here, this is radioactive as well. When you make mud bricks, the mud bricks contain radioactivity. They give out radiation. Now, where does that come from? Where does this radioactivity in the rocks come from? It comes from the day when the universe was created, when all these rocks were created. This radioactivity is older than the age of the Earth. We can't escape from it. It's all around us. And the third source of radiation is man-made. We make it ourselves. We may do that through the making of nuclear power stations or nuclear bombs, but we also do it in more simple ways. For example, X-rays. X-rays are radiation, just like the third type of radiation I'll tell you about later called gamma rays. X-rays are radiation. Every time we go for an X-ray, we're being subjected to radioactivity in effect. And in a moment, we'll go and look at an X-ray machine in the hospital here in Thimphu, and we can see that radiation is not always bad. Radiation can also be very good and very helpful, but we'll see that later. But it's not only cosmic rays from outer space, it's not only the rocks and the sand and the soil and the mud. Rivers, water is radioactive as well. And believe it or not, so is food. You go to the vegetable market and you look at all those clean vegetables there, they have a small amount of radioactivity in them too. And just as a matter of interest, a Brazil nut is 1,000 times more radioactive than a potato. So natural background radiation is with us all the time, and the human body has learned to get accustomed to it. So it's not really harmful. When radiation becomes harmful is when we get too much of it too quickly. And so we're obviously very concerned about things like leaks of radioactivity from nuclear power stations, from nuclear bomb tests. But you might say to yourself, as we stand here above Thimphu, we don't have nuclear bombs in Bhutan, we don't have nuclear power stations in Bhutan, background radiation we're totally used to, so why should we bother about radioactivity in Bhutan? Well, you just think, north up there is China. South down here is India. Both these countries do have nuclear bombs. We hope there is never an accident. And in China, they will shortly start the construction of 47 nuclear power stations to generate electricity. Down south too, India is going to build a lot of nuclear power stations, and we've seen how in Japan an accident in a nuclear power station can affect places hundreds of miles away. An accident in a Chinese or an Indian nuclear power station could bring radioactive fallout over Bhutan. So we should understand it. It's very important that we are aware of the dangers, that we're aware of how to protect ourselves, but also that we're aware that radiation can sometimes be very helpful. So apart from natural radioactivity in the rocks and in the sand and in the soil and in the mud all around us, we've got natural radioactivity too in the river water. But one of the significant sources of natural radioactivity is actually in building materials. And those building materials might be granite, or they may be cement or concrete, and they all contain or act as sources of radioactivity. So we can't escape from it. It's all around us, and our bodies have over thousands and thousands of years become totally accustomed to dealing with it. So it's a really surprising thing. Even these bananas, delicious looking bananas, and all this delicious fruit here actually contains sources of radioactivity. All our food, almost all our food, and all our water contains sources of radioactivity as well. So every time you eat, every time you drink, every time you think of this lovely organic fruit, remember, you're actually consuming a little bit of radioactive material. Nothing to worry about. Our bodies have got used to it. One thing our bodies have not got used to, though, is another source of radioactivity, which is cigarette smoke. Now, you don't read about this. When we talk about the dangers of smoking, nobody mentions the fact that the smoke from a cigarette is radioactive. It contains an element called polonium. And this comes from the fertilizer that is used when the tobacco plant is grown. The fertilizer gets onto the leaves, and then when the tobacco is made, the fertilizer remains there, and the radioactive polonium in the fertilizer stays in the cigarette. And when you inhale the smoke, you're inhaling radioactive polonium into your lungs. Now that could well be a significant element in the cancerous effects of tobacco smoke. Human beings are radioactive. Our bodies are radioactive. There are all sorts of radioactive elements in our bodies, and if we stay close to somebody, we are getting radioactive radiation from them, and we are radiating them as well. So how can we avoid it? Every time you stand near your friend, you're exchanging radioactive radiation. Another source of radiation which is all around us these days is the mobile phone. Now, the radio waves which come to and from a mobile phone, they're given out by your phone, you receive them when you receive a call. Those radio waves are exactly the same thing as gamma rays, with just the difference that they're a slightly different frequency. So we're getting radiation from our mobile phones too. So the more friends you have, the closer you are to them, the more often you make mobile phone calls to each other, the more radiation you're getting. So my point is this: radiation from radioactive sources can be very, very, very dangerous. We can't avoid it. It's all around us. The key is to make sure we don't get too much. Let's pay a quick visit to the Jigme-Dorjiwangchuk National Referral Hospital here in Thimphu, and let's have a look at an X-ray machine. One of the main sources of the background radiation that we receive very often in our lives, it comes from X-rays. And here we are at the X-ray department in the hospital, and this man is going to have an X-ray which will give him a dose of radiation. Now, X-rays are very, very similar to gamma rays, and so too much radiation from X-rays can be dangerous. So one therefore should not have X-rays without there being a good reason. So X-rays are one of the main sources of background radiation that we receive every day in our lives. Let's go and look at the machine that produces the radiation. Here we are in an X-ray room. This is the machine that produces the radiation. So X-rays come out of here, and remember, X-rays are the same as gamma rays. There's just one little difference. And the X-rays come down here, and they're so energetic, they're so powerful. They go through the body, and there is a film, a chemical film underneath here, and they leave an image on the film. So every time you have an X-ray, you're receiving radiation. If you have too many X-rays, that's obviously dangerous. Now, we saw earlier on in the program that X-rays can be quite dangerous because they're just the same as gamma rays. But the fact of the matter is, here we have this patient under the X-ray machine, and thanks to our X-rays, we can have an image of his bones and of the inside of his body. So X-rays, apart from being a little dangerous if you have too many, they bring us many, many benefits in terms of medical imaging. And without X-rays, the whole of medicine would be significantly hampered. So the benefits, but the dangers. And one of the most recent techniques using X-rays is called the CT scanner, computerized tomography. And that uses X-rays, but in a rather more sophisticated way with computers to create the most wonderful and detailed images of the body. Let's very quickly go and look at a CT scanner. So here we are in the CT scanner. CT stands for computerized tomography, and it uses X-rays, just like the other X-ray machine, but it also uses very advanced computer technology in order to generate the most wonderful images of the inside of the body. And as you can see, the CT machine is a complicated piece of equipment. Here we are. This is the CT scanner. The patient lies here, and when it's all ready to go, the patient is slid slowly through this big hole. And you have a little device which gives out X-rays here, but the difference is this: it actually rotates through a complete circle. And this is what gives us the wonderful internal pictures. So as the X-rays are coming out in a circle, the patient's body slowly goes through and generates an image, and we'll have a look at the sort of image that we can get. So just to remind you, there are 3 sources of background radiation that we're subjected to in our lives. One comes from outer space, the other is natural, and the third is man-made. And X-rays are one example of man-made background radiation. But you see, they can be dangerous, but they can also be very, very helpful. If you have too many, it's dangerous. But then the use of X-rays in medical imaging, medical diagnosis, the benefits far outweigh the dangers. So we've seen examples of radioactivity outside, the X-ray machine. We've looked at rocks and sand which are radioactive. We've said radioactivity is everywhere. We know radioactivity can be dangerous. So what I'd like to do is to make sure that you know, where does radioactivity come from? And in order to answer that question, I want you to think back to what you've learned about the atom. And you may remember an atom is made of a nucleus, and the nucleus is surrounded by a cloud of electrons which orbit round and round and round. Now, the first thing to remember is that radioactivity comes from the nucleus of an atom. From the nucleus, it's nothing to do with the electrons. So let's get rid of the electrons. And let's look at the nucleus. Well, you may also remember from what you learnt about an atom that a nucleus contains 2 types of tiny, tiny little particle. Some are called protons and some are called neutrons. Now, if we take a hydrogen atom, that is just 1 proton with an electron going around. It's just got 1 proton in it. Hydrogen is not radioactive. But if we look at another example of an element called uranium, that's very much heavier than a hydrogen nucleus. In fact, it's 235 times as heavy. And the uranium atom is called U-235. And it consists of 92 protons and 143 neutrons, which add up to 235. So packed into this tiny nucleus are 235 little particles. Now, it's a little bit like a cinema. If you think of a cinema, If there are too many people in the cinema, it's too crowded, some people get shot out. They get thrown out of the cinema. The nucleus of uranium-235 is just like an overfilled cinema. It's got so many particles in there that it is unstable. And an unstable nucleus has somehow to get rid of the extra particles. And that's what the nucleus of uranium-235 does. It shoots out some little particles. And in this case, it shoots out a little particle which contains 2 protons and 2 neutrons. And that comes whizzing out like the bullet from a gun. Now, this sort of little particle, containing 2 protons and 2 neutrons, is called an alpha particle. Sometimes an unstable nucleus will shoot out another sort of particle which consists of an electron. But please note, this electron comes from inside the nucleus. It doesn't come from all those electrons going around the outside. It comes from inside the nucleus. And the electron that might get shot out is called a beta particle. Alpha and beta, the first 2 letters of the Greek alphabet. And they have a little shortened form, alpha and beta, 2 Greek letters. Sometimes it also shoots out a little wave of energy. If you can imagine in the cinema, you've got 50 people too many in the cinema and somebody comes along and throws 50 people out. Sometimes when they're being thrown out, there'll be an awful lot of shouting and fighting. In other words, energy. And in a way, that's what this little wave of energy is. It's not a particle, it's a wave, it's an electromagnetic wave. And it's called a gamma ray, the 3rd letter of the Greek alphabet. You notice it's not called a particle, it's called a ray, and the symbol for that is the Greek gamma. Now, these electromagnetic waves are pure energy. And when they come shooting out, they're very energetic indeed. And they are, in fact, exactly the same thing as the radio waves that come into your mobile phone. They're exactly the same thing as the radio waves that bring television to your television set. But there is a big difference. Compared to a radio wave, these gamma rays have got a very, very, very high frequency. And that's what gives them so much energy. So, where does radioactivity come from? It comes from an unstable nucleus of an element. What does that element do? It may shoot out alpha particles or beta particles, and sometimes at the same time it shoots out an electromagnetic wave called a gamma ray. And all that is what we call radioactivity. Radioactivity is the phenomenon, is what happens when an unstable nucleus shoots out alpha or beta and gamma rays. So when we talk of radioactivity, that's what we're talking about. So let's just look a little more closely at an alpha particle for a moment. An alpha particle, you'll remember, 2 protons and 2 neutrons in a little pellet of matter. And they come along and they are very easily stopped. First of all, they'll only go through a few centimeters of air. They're also stopped by a sheet of paper. But also, most importantly for our health, an alpha particle is stopped by the skin. It doesn't go through the skin. This means alpha particles are not too dangerous unless you actually swallow something which is giving out alpha particles. Now, I mentioned earlier, and I showed you a little smoke detector, we get alpha particles being used in a smoke detector, which you've got in your room. No danger, because the alpha particles will be stopped by just a few centimeters of air. Let's look at a beta particle, which you'll remember is an electron. Well, that doesn't actually carry very much energy. It will penetrate through a sheet of card, but it's stopped by a thick sheet of cardboard. It doesn't carry much energy, so it's not too damaging. But let's look at the third thing that's given out in radioactivity, which are gamma rays. And you'll remember gamma rays are not a particle, they're a wave. Very energetic, high frequency. Now, these gamma rays are very, very penetrating. To stop a gamma ray, you need about 10 to 15 centimeters of lead, solid lead. A little will even get through the lead, but not too much. And because gamma rays can penetrate through concrete and through skin and through wood and through bricks, through the walls of this room, they are very dangerous. Gamma rays, high frequency electromagnetic waves. They do a lot of damage. If they get through the body, they harm the cells of the body. They can alter the DNA in the body, and they can cause cancer and genetic problems. So gamma rays, the most dangerous of all the 3 radioactive emanations. The further you are away from the source of gamma rays, the less the energy. In fact, one way of protecting ourselves is by distance. If this was a radioactive nucleus giving out gamma rays, if I am very close to it, the gamma rays will do a lot of damage. But as I go further and further away, the amount of energy that the gamma rays have gets less and less. In fact, if I increase the distance by 100 from, say, 1 centimeter to 1 meter, then the intensity or the energy of the gamma rays goes down by 10 squared. In other words, it's only 1/100th of what it was before. So keeping a good distance from a source of gamma rays is one way to help protect ourselves. The other way, of course, is to have a thick lead box around the source of gamma rays. Well, we can do that in laboratories and hospitals. We can't easily do that if we've got radioactive fallout producing gamma rays. So the thick lead box is not generally useful. So, alpha particles, beta particles, and gamma rays. The most dangerous are gamma rays. However, we were down in the vegetable market a little earlier in the program. We saw all this fruit, and I will have reminded you that you can actually use gamma rays to preserve fruit. If I took a banana, or even better, a strawberry, and fired gamma rays at it, that strawberry will not go bad for probably 3 months. So irradiating fresh fruit with gamma rays is one way of preserving the fruit. Now you'll say, but surely if I irradiate my banana with gamma rays, surely the banana is radioactive. No. Just because the banana has been radiated by gamma rays does not mean that it has become radioactive. And it's the same with people. If we look at all that footage of the nuclear accident in Japan as a result of the earthquake, and we see people who are being tested for radioactivity, it isn't the person that has become radioactive, it's all the dust which is on them, which is on their clothes and on their body. That is what is radioactive. And that is why, if by accident you get radioactive material on your body, the first thing you have to do is have a very, very good and thorough shower to get rid of it. So to end this short program about radioactivity, I'd like to remind you what Class 10 students need to know about radioactivity for their examinations. Well, first of all, you need to know what is radioactivity. Secondly, where does radioactivity come from? Thirdly, you need to know about the 3 types of emanations that come with radioactivity: alpha and beta particles and gamma rays. Fifth, you need to know some uses of radioactivity, and we've seen plenty of examples of where radioactivity is useful to us. You need also, though, to know about the dangers of radioactivity. You need to know that if you're subjected to gamma rays, they can cause cancer and genetic mutations or changes in the genes. You need to know that gamma rays and alpha particles can cause cancer. So you therefore need to know how to protect yourself from radioactivity. And there are 3 main ways. One is keep your distance, stay away from a radioactive substance. Secondly, shielding. In the case of gamma rays, put thick layers of lead between you and the radioactive source. And of course, thirdly, security. In a laboratory or in a hospital, you don't leave radioactive sources lying around on a table. You lock them up securely. If we think of our nuclear bombs are surrounded by a great deal of security. If we think of nuclear power stations, we can see there all the concrete and the lead shielding that's used. And also, a nuclear power station is a high security zone. And then lastly, you need to know that radioactivity is all around us in our everyday lives. We saw that the sources of background radiation can come from building materials, come from rocks, especially granite, as well as these sources of radioactivity which are useful to us, for example, in X-rays. So I'd suggest, when you're doing your revision, look at all of these 8 points. and make sure you understand them. And I hope this little program has helped you learn a little bit more about radioactivity.